So good day guys, welcome to this video. So what we are doing in this video is echo. So what is echo? So echo is the repetition of sound due to reflection of sound wave. So that is echo. Now this is the formula that is applicable to echo. Now the reason why this is the formula is that you know that normally velocity is what is displacement over time. Do you know? I hope you understand. But and also speed is equals to what? Distance over time. Now this is what happened in echo. The sound will go like this. Let me tell you. The sound will firstly go like this. If you are maybe you are the one now, you are now shouting. At times whenever you are shouting, you will notice that when you are in a free space, maybe you are the only one present in that place, you're going to notice that the sound is going to be coming back to you. So it means maybe you stay, maybe this is a mountain. This is a mountain now. You are now shouting, and starting is somehow pulling the sound back to you. So that's what we call that's a part of the reason why we say it is what an echo. But if you look at the stand firstly went in a particular distance. Do you know that? So it firstly went in that same distance, and it came back. So because it came back, the first distance, let's assume it is x. The second distance, let's also say it is x. If you add them together, you're going to be having what? 2x. So that's why I said the formula for the speed, though this v, you can represent it with speed. So it's now what? 2x over t instead of x over t. So the reason is because this in echo, there will be repetition of sound. So that's why we said it is what? 2x over t. And what is x? So that is distance. That is what distance. V is the speed of sound. And our t, you know that t is always what? Time. Let's move to the examples. Now they said a man hears a thunderstorm. You know that thunderstorm is an application of echo. So a man hears thunderstorm 3 seconds after observing the lightning flash. How far is he from the thunderstorm if the speed is what? Speed of sound. That's what they want to write. Speed of sound in air is 330 meter per second. So our time is what? 3 seconds. And they said how far is he from the thunderstorm if the speed of sound in air is 330 meter per second. So that is what our velocity, our speed, that is 330 meter per second. And you know our formula. What's our formula? V is equals to, it asks us to find alpha. I know you should by now you should know the meaning of the statement alpha. Alpha means the distance. So this is our formula, 2x over t. So they're asking us to find alpha, which is what? Distance. So let's cross multiply. So we have vt is equals to 2x over, divide both side by 2, divide both side by 2. So we now have what? X is equals to vt over 2. So what's our v? 330. What's our t? That is 3 over 2. So let's quickly do that on our 2 here 1. 2 in this one, we have 1, remainder 1, so we have 65 times 3. Let's quickly use our another 2. So our final answer is what? 495 meter. So that's our what? That's our distance. 495 meter. So that's our distance. So that's that question. So the answer is what? 495. So let's move to the next question. So they said a boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. If the speed of sound in air is 340 meter per second, how far is he from the hill? They give us speed of sound in air, which is what? V. You know that the speed of sound is 340 meter per second. They now said our time is 0.8 seconds. They now give us how far is he from the hill. That is, how far is what? X. So now let's look for our alpha. So v is equals to 2x over t. Now let's cross multiply. We now have vt is equals to 2x divide both side by 2. So x now will be what? So our v WD-40. What's our T? 0.8. What's our so we have 2 here. So our answer here is what? 136 meter. So you can see how easy it is. So the formula is quite easy. The echo is a very simple calculation. So if you can know the logic, that's that. So let's move to the next question. They said a man shouts. This question is quite different, but if you are a good physics student, you'll be able to know it. If you are a attentive student, you'll be able to know it. They said a man shouts and receives the echo. And receive the echo from a nearby hill 6 seconds later. If the sound emitted by the man has a frequency of 250 Hz and a wavelength of 1.2 meter, how far is he from the hill? So they gave us what? Time, which is 2 seconds. They gave us frequency, which is 250 Hz. They gave us wavelength, which is lambda, 1.2 meter. They now ask us to find how far, that is, they ask us to find x. So now, how you find x? And you know the formula is what? 2x over t. How can we not find x having only time? So it means we are going to find what? Our v. So that the reason why they now give us f and lambda is because they know that we can use the formula v is equals to f lambda. So after finding that v, the v here, we are now going to substitute it here and we are now going to find our x. I hope you understand the logic. So it's nothing. Don't be afraid when you see a question like this. So our f is 250, our lambda is 1.2. So 250 times 1.2 is, so that is 300 meters per second. So that's our v. So let's substitute. So v now is 2x over t. So at the end of the day, we're having vt over 2. I hope you understand. What's our v? Our v is 300 and our t is 2. It's not every time you'll be looking for x. It's just like the question I chose is about finding x. So 300 meters. So our answer is what? 300 meters. So how far is it from the hill? The answer is 300 meters. So that's for this video. Bye.